All right. Good afternoon. I'm Shung-Hsi. I'm part of the Hardware Enablement Taipei team. So my talk, kernel testing with GitHub Action, which is basically running BPF self-test. So BPF self-test is a test suite for BPF testing for the Linux kernel. It's part of the Linux kernel source code and it's integrated, and upstream BPF maintainer have very strict rule on making sure the features and the bug fix have a corresponding test in the BPF self-test. I would say it's quite well maintained. And I have this run in basically what is GitHub's CI/CD. It's called GitHub Action. And the talk is actually very short. It should be like 10, 15 minutes. I'm hoping this will be more of a discussion than a talk. And the reason that it's short is because it's very low on technical details, but you'll see. So how it started. So back in 2021, I got handed over the maintainership of BPF from Gary Lin. And it's a pretty fun time. So a lot of security research are done on BPF. There's many fixes on the BPF verifier. And also a few years back, there's Spectre, which eBPF was also quite useful there. Um, so yeah, I begin to wonder after so many backports, like, am I really doing the backport correctly? Like, is there any bug? Which is quite a natural question to ask. So in 2022, when I backport, I begin backporting BPF self-test patches. So as I said, whenever there's a fix for BPF, usually and hopefully there's a BPF self-test that makes sure that there's no regression and the bug is actually fixed. So I backport those BPF self-tests whenever I could. And then I try to run the BPF self-test on the 15SC4. That was quite a while back. And it kind of worked. Like I could run the self-test, and some are failing. I don't know why, but the BPF verifier test passes. So I'm happy enough and call it a day. So in 2023, I finally were able to come to LabsConf and talk about how I backport BPF. And during the talk, I mentioned that I am backporting BPF self-test patches to our kernel. So the kernel QE team reach out and say, hey, like that's an interesting work. We'd like to get BPF self-test tested as part of the kernel QE workflow on OpenQA. So one of the requirements for that to happen, or at least the preferred approach, is to have the BPF self-test package into RPM. And that turned out to be a lot of work, like more than I thought it would be, partly because BPF self-test is not expected that it'll be packaged to RPM. So I have to kind of fight the RPM beside finding all the dependency. That took quite a while and I wasn't able to complete. But in 2024, I was finally like able to massage it into some form of RPM with ignoring some RPM warning. And with that and the help of kernel QA, I was able to have it running in the kernel QA's in the open QA basically. And again, like the BPS self-test kind of works. Still many failures, but the good thing is the test verifier is also still passing. So I'm happy enough. But then the CVE tsunami came and I couldn't find more time to look into it. But we're supposed to try to look at all the failures and try to make it pass, or either decide that we should ignore it, but that never happened. So in this year, I had a talk on BPF and stable kernel at the LSF BPF. And the point of my talk was basically, hey, we should run BPF self-tests for the stable kernel as well. Specifically upstream stable, but yeah. And the suggested I got from the BPF maintainer upstream is to use BPF CI. BPF CI is basically just GitHub action script that runs the BPF self-test on the BPF next, which is the BPF development tree. And that's basically what I did. So I forked the BPF CI script on GitHub, And I basically just pointed from BPF next and I switched to the stable Linux 6.12. And that basically worked surprisingly. Like there's two things I had to fix. It's like one is to make sure that I can clone when cloning using something other than the master branch would work, and the other I actually forgot. Like it's very little challenge to do that. So I think I was able to do that within like 1 or 2 days. And after that, I expanded the test to our SL 6.0, and then also to stable 6.14 and to mainline. So how is going? So right now, beginning since May, so this month, every day the BPF self-test is run on the mainline 6.14 or SL 16.0, which is basically aligned with 6.12 in terms of BPF subsystem. And if there's failure, I get an email from GitHub. If there's no email, that means everything is passing, so pretty good. And if I want to look at the history, I could just use the GitHub web UI. So you just go into the action tab, which is new, and there all the GitHub action history is recorded. So for example, I could see like this one is passing from 1 hour ago, and the tests overall took about an hour, which is kind of acceptable. And if I go inside, I can say that I can see that oh, it tests the stable 6.14, 6.12 mainline, and the SUSE's SL 16.0. And if I go into that, I can see the complete like test run, the logs, and BPS have some script that basically collect the information into a more digestible format for the GitHub action. And so what's it useful? So far, I think I started running a bit later than at the end of April, I think. So when I started, it's only 6.12 and eventually SL 16.0. So a bit less than a month so far, and I already caught two issues. One is there's a fee realloc regression in the mainline. So what happened is the BPF verifier is running about 40 times slower in the worst case, and the BPF self-test overall was running 2 times slower. So I was able to catch that, report the regression, and it's fixed. And the other issue is that there's a BPF verifier fix missing in the stable. And the reason that I was able to find it out is that because I have more BPF self-tests backported in our SL 16.0. So when I finished the work on 6.12 and I switched to our SL 16.0, I realized that, oh, actually something is failing. And when I look into that, it turns out to be some missing fix. And backported, it works. And so here's just a very brief introduction on how the GitHub action is run. So basically, it has some declaration file in the Git repository under .gitlab workflow YAML. And each workflow will execute some jobs. And job is basically just a sequence of action, and action is just some bash script, or it calls into more complex script that is hosted on other part of GitHub. And the script I'm using has a schedule, so like familiar cron schedule, it runs every day, and it uses VM test OpenSUSE YAML workflow, which is mainly copied from the BPF next VM test YAML file. And unfortunately, it's not using OpenSUSE, but yeah, I don't have time yet to work on that. So the thing is very simple. Like the first step for setup environment, install all the dependency has already been figured out by the BPF upstream. So I'm using the libbpf CI setup build environment action to do all the hard lifting. I actually don't know what it does, but it does work well. So after you set up the environment, I have it clone the OpenSUSE expanded tree on GitHub. And as you can expect, configure the kernel. The only special thing I would say is that I had to use a specific config that's made for running BPF self-test, and that's main part, and then add some SUSE stuff, configure, compile, and building the self-test, the BPF self-test is also a bit of an annoyance. It's kind of hard to get working, so I'm glad that they had an action for that. You said don't know how it works. And the last step is this the BPF CI run VM test. So basically, it just starts a VM within the GitHub runner environment. Use the kernel that's built, use the BPF self-test that's built, run the self-test on top of the build kernel, and report the result. And that's how I get all that report. And so far, so good. But for future work, I think there's some more work that I could do. 15 SP7 will be maintained for a long time, so hopefully get it working there. And it's quite aligned with 6.6, so I could try that as well. And the one of the, I think, more important part of future work is that instead of running the BPF self-test that is included in our current kernel source, one thing I was suggested is to run the latest BPF self-test in the BPF next development tree. In theory, the kernel self-test, case self-test should be backward compatible. So you could run the latest self-test, for example, if you want to test C group, you could run the latest mainline C group test on our SUSE kernel, and it should work. But unfortunately, BPF special, and it's pretty hard to get it working. For one, it builds a kernel module. For the other, like there's a lot of tests that is accessing the kernel data structure, and things change. So that's quite hard to do. But if it was done, and if I can determine what tests are for new feature and what tests are actually testing some bugs, then I should be able to figure out a lot of more bug that we have missing fixed. And the other thing is that try to test more architecture, compiler, and a random idea that I think I talked with Fabian, and he said it might not work, but is have some sort of attestation. So have some third-party GitHub prove that they run this test on this Git kernel commit, and BPF self-test really worked. And sort of a proof that is better than me talking to our partner saying, hey, it works on my machine. I don't care why it doesn't work on yours. And yeah, that's the main thing. So a bit of thought. So I think doing it this way is really, really easy. And that works great for me. And the other thing is that this is building on the work that the upstream, mostly meta people has done. So I had some changes. I could just submit it back. And there's no need to maintain the machine myself. Don't need to worry about common criteria, because I run a bunch of script. I don't know what it's doing. So I probably don't want it on our R&D network. And the result is publicly available. I could just point a link to, if there's some failure, I could point the link and people could look at it. And it's automatic. It's same time scheduled to run automatically, so I don't forget it. But at the same time, if I want it to be run right now, I could do that. That's also great. So there's very little thing that I don't like, but of course, the biggest part is that it's not integrated with a SUSE QE workflow. So I couldn't like have the QE colleague to help me looking into that. And it cannot test internal branches, but that's not too big of an issue because those are older, and I'm not even sure I could get BPF self-test working on that. But yeah, that's mostly my experience. I have a few more slides, but I think I'll pause here and see if there's any feedback, comments, or thoughts, and take a chance to grab the water.
I saw that QA runs self-tests for the regular thread kernels, if I remember correctly.
We run very little subset C groups and something else, I guess. And BPF, those are the biggest case of test, and we weren't even able to compile them for older slash. So
So the obvious question is whether we can extend the coverage of the self-tests. What is the problem?
at the past we had we thought we would just cherry pick what is interesting in case of test and port it to LTP because that's has much better API and cares much better about the past. So later case of test declared that they care about the past, but BPF doesn't care about the past. And also there's the problem with that if you need a special config, it's a question whether you really test your distro kernel.
Yes, but in the case of distro kernel, we concentrate on our own configurations. So mainly, of course, the question will be different to catch up the upstream regressions and so on. But for our own, so yeah, business purpose, I think that just checking the yeah, only for our configuration should suffice.
Yeah, so for BPF, I tried a part of the time I was trying to have it run on our own kernel config because, as you said, like it should test our distro kernel, and I tried that for quite a while, and I think I had like 2 or 3 patches to get it working, but in the end, that turns out to be a lot of effort that is it's really hard to get working.
And also, I regret that they didn't choose GitLab instance because maybe it's not wise to run it on R&D, our private GitLab instance. But if we check that, it would be good to run it on internal branches. Maybe it might not be that difficult to backport, to adapt that to run it on GitLab. Thanks a lot for doing this work. We come to that and investigate what it actually does.
Yeah. So the next question is whether we can run more other tests in the similar way on GitHub test, GitHub runner.
I think it's possible. Like at least like with the GitHub runner, it should be possible. Like BPF self test should be the hardest one to run. So if it could work there, I think it should work for other.
Yeah, sorry. The last question is whether it can be done without compiling the kernel. I mean, we can just take our own kernel and yeah, the builds, of course, self-build stuff, but other than that.
So it could work, but the problem is the kernel module. So the BPF kernel module is responsible for many part of the test. So if it's not if it cannot be loaded, yeah. So there's some detail I haven't figured out, and one is how to make sure BPF kernel module is loaded successfully with even though it's not compiled for that kernel, and I couldn't figure it out despite there's KABI stability, and that was part of the issue. So if that is figured out, we should be able to run it, and some tests will be. Yeah, I think it should be possible, but I couldn't figure it out yet.
Okay, thank you.
So regarding the question if we can run more test cases, we can always run more test cases, but who's going to maintain that and look at the results? Because in this particular case, we are actually getting stuff for free because Meta maintains the scripts. and that's easy. But if you start adding more of the self-tests, suddenly you're the one who is maintaining the scripts and who is looking after the infrastructure. And even then, if you manage to do that, somebody has to look at the failures. And that means that that's basically full-time job. So we would need to hire someone to do that. So it's kind of pointless to run more test cases if you do not have people who are looking at the results and fixing the bugs.
Hello. We at the live batching team, we are also thinking about using the current upstream to test older kernels since it's backwards compatible, and also we try to talk with people. At least it was some years ago, and the QA people didn't want to use self tests because they said something was broken and nobody was fixing that. But yeah, thinking that it could use GitHub CI or GitLab, something like that, easily is nice. So I will take a look in your IMLs to check what you did. So thank you
Right.
for that.
I wanted to comment on the possibility of running more self-tests. That there is also Rapido cut. It's called cut, where you can build self-tests into this Rapido image. So I know it works for C group self-tests, but I don't know about the other groups of self-tests. So because I noticed that you have custom GitHub action particular for BPF self-tests. So there's some more complex setup. So I wanted to mention the Rapido, and also as said by Cyril, yeah, I think if QA runs it, so then it becomes from self-test, it is like dem tests. I mean that the self-test is like or the meaning as I understand it is that like the developer themselves run their tests, or they run it for their purposes. So there is the loop is closer.
Yeah, that's true. So could I switch back to the slides? I actually have a few. Yeah, so there's actually a lot of related concept. Like we have SUSE build, OpenQA with LTP, GitLab CI/CD, and there's a lot of tools that's also related. Rapido, the BPF CI use VM tests, but Rapido is what I think Miko mentioned, and with, but with all the CI/CD stuff, like on GitHub, it's actually it's not uncommon to see other um, project that is using this. For example, the Futures team micro OS tests is basically just a single script that runs on GitHub and boots a VM that runs some specific tests within the VM, and that actually works from them. So I think there's quite some potential there. Yep. And the slides can be found on Slack. And I guess like, so if I were to try this again, I think I'll go for less pragmaticity and less perfectionism, or at least that's what I think now. Like maybe I could give up sooner on this like trying to run on the SUSE kernel config, maybe, and just forget about packaging and just try to have it run somewhere regularly. Like have it, in a sense, make sure that it works for me first before trying to integrate it into OpenQA may be a better idea so that I'm more familiar with all that stuff. Yeah, that's the takeaway I have for now. All right. I think that's the end of my talk. Thank you for coming.